Hello everyone, so now I'm going to present to you an example of integration by partial fraction. Number 1, the problem is integral of x minus 9 over x plus 5 times x minus 2 dx. So the first part, we will separate the two denominators and label them as a and b. So this is what it looks like. A over x plus 5 and then plus b x minus 3. So you just write here x plus 5 times x minus 3. And then we will try to pair this to a. Since there is x plus 5 here and there, if you try to pair this, they're the same, you just cancel them out, which makes the x minus 3 the only remaining equation. So it will become a x, oh, it's actually x minus 2, I miswrote it. It's actually x minus 2, I apologize. And then same for the b, since x minus 2 here and there is x minus 2 over here, what we will leave here behind is x plus 5, b x plus 5. Also here our equation, which is x minus 9 equation. So we will solve for a, which is negative 2 wait for a second. It's negative 2, so we're just gonna convert it to positive. Let x be equals to positive. And now this will be 2 minus 9 equals a 2 minus 2 plus b, which is 2 plus 5, and then just continue. 2 minus 9 equals to negative 7 equals a is 0 and then plus b, which is 7. What's gonna be here? We have to divide them out by 7 to get here, to get the b here, or to get the a here. So try to calculate. So our answer here is negative 1. It's actually b. So that is our answer. Now for the second part, we will try to calculate now. Now time to solve for a. So instead of positive 5, let x be equals to negative 5. Also same process, x minus 9 equals to a x minus 2 plus b x plus 5. Now let's solve. Since it's negative 5, negative 5 minus 9 equals a negative 5 minus 2 plus b negative 5 plus 5 0 negative 7 negative 5 minus negative 9 is negative 14. So we have here negative 7 here. You have to divide by them by negative 7 to get the a. So the answer will be 2. 2 will be a. So now just took negative our b is negative 1 and then our a is 2. Since it's both negative here. Now what you're gonna do now, just copy the original problem, which is integral x minus 9 x plus 5 and then x minus 2. After that we substitute it with our with a and b here. Now to become our a is 2, so it's gonna be 2 over x plus 5 and plus negative 1 x minus 2. Just separate them to integral of x plus 5 dx plus negative 1 it's not integral, it's negative 1 integral of x minus 2 dx. Also add dx here and then we just integrate them, making the answer will be 2 ln of x plus 5, since it's negative 1, it's understood as ln minus ln of x minus 2, and then arbitrary constant plus c. We have now final answer. To ln x plus 5 minus ln x minus 2 plus c. And now so we're back for the second problem, which is integral of 1 over 1 plus 4. Oh, it's not 1 plus 4, it's t plus 4. I'm actually based what I'm seeing in my cell phone, so it's not clear. T plus 4 times t minus 1 dt. So it's still basically the same, they just change it to t. First thing we do, separate the two equation in the denominator. A t plus 4 plus b t minus 1 dt. Oh, you no longer need to put that. And then you just look at this. You can put these two here and then compare which one has the same or which one has similarities, and you just cancel it out. So the first thing, t plus 4, and then t minus 1. If you place it here and look for something similar, you know it's t plus 4, so you have to cancel them, making a equals to t minus 1 plus b t plus 4. Okay, and then 1 equals it. Since there are no t here, you just have to let it be on its way. Just copy and bring him down whenever you solve. So let's try to solve it now. You have to let our t be positive 1, it goes to a t equals positive 1, 1 minus 1 equals 0, plus b 1 plus 4 equals 5, 1 5 over oh, it's 5 here, just divide by it, making it RB as 1 over 5. Now for RA, let t equals to negative 4, and we try to solve it now. Just copy one. A goes to negative 4 minus 1, and then negative 4 plus 4, so it's 0 here. Negative 4 minus 1 will become negative 5. Just copy 1 here. Then 1 equals to negative 5 divided by itself with negative 5, making our answer negative 1 over 5 A. And I just copied the the original problem, which is 1 over t plus 4 times t minus 1 dt. Then substitute a and b. Ra is negative 1/5 over t plus 4 plus again RB now, which is 1 over 5 over t minus 1, and then we just try to integrate or apply it first. Now you have to separate this 1 over 5, negative 1 over 5 integral of t plus 4, and then plus 1 over 5 integral of t minus 1, and dt. Now let's just solve. Goes to negative 1/5 ln of t plus 4 plus 1 over 5 ln of t minus 1 plus the arbitrary constant. Or we can also try to equals to 1 over 5 ln of t minus 1 minus 1 over 5 ln of t plus 4, and do not forget again the arbitrary constant. So here is the final answer. Thank you for watching. Hello everyone. So now I'm going to be presenting to you an example of integration by parts. And this time I'll be using a DI method that Sir taught us. So without further ado, let's start. Our problem is integral of x to the 4th power times sine 2x dx. So the DI method looks like this. It focuses our d is differential and our I is integration or integral. So we focus on u, on the d, and on the I, where we will be focusing on the trigonometric and identities. We have x4 here. Just continue to put this places their derivative. 4x cubed 3 times 4 equals 12 x squared 12 times 2 equals 24 x 24 and then 0. In the meantime, place the sign here, sine 2x, and then integrate sine 2x equals to negative cosine 2x over 2. After that, we can multiply cosine 2x to negative 1/2 here. So it's become like integrate negative sine 2x and then multiply denominator by 2. 2 times 2 equals 4. And then look for the integration of negative sine 2x to become cosine 2x over 8. Just multiply the denominator by 2. And then after that, look for the integrate it again, become negative. It's not negative, but sine 2x over 16. And then just continue the final process up until the 0, which is will become again negative cosine 2x over, by the way, I'm writing already here, (16 times 32). 16 times 2 equals 32. Well, and this is how we try to place the answer. But we also need to place conventional signs, which we place here: positive, negative, positive, negative, positive, and then negative. So for this first one, we multiply x to the 4th power with negative cosine 2x for 2, it will become negative x to the fourth power over 2 sine 2x. We basically solve the the other part, but this time we leave one behind. I forgot the term that you called it, but you just follow this pattern and then and for 4x cubed, they're both negative, it's gonna be positive. 4x cubed over fourth power sine 2x, and then the 12x squared times cosine 2x over 8, it will become now 12x squared over 8 cosine 2x. Another one is negative 24. Negative 24 will be multiplied with with sine 2x, so it's gonna be negative 24 over 16. Don't forget place x here. Sine 2x, and then for the other part, for the last one is 24. Positive 24 will also become negative due to negative cosine here. Negative 24 over 32 cosine 2x. So now that we have the numbers now here, this will be the answer. Negative x to the fourth power over 2 sine 2x it's actually cosine, I apologize. Apology here, plus 4x cubed over 4 sine 2x plus 12x squared over 8 cosine 2x. By the way, we can simplify it maybe later, just try to list them all down here. Minus 24x 16 sine 2x, and then minus 24 again over 32 cosine 2x. Up. So let's try to rewrite. Goes negative x to the fourth power over 2 cosine 2x plus 4x cubed over 4 sine 2x plus, let's follow it, plus 12x squared over 8 cosine 2x minus 24x sine 2x. Don't forget to place 16 here, and then minus by 24 over 32, which is also 3/4. minus 3/4 cosine 2x plus arbitrary constant. So there we have the first example. Hello everyone, so now I'm going to presenting to you the second example of integration by parts. So the problem is integral of x cubed ln of x dx. We try to categorize them and try to place them in their respective so that we can place it later in our equation or in our formula, which is integral of u dv is equals to uv minus integral of u v du. So our u will be ln of x, and then the derivative of ln of x or du will be 1 over x. Also our our dv is x cubed dx, and then the antiderivative is x to the 4 over x over 4 over 4, or I apologize, it's x to the 4th power over 4. So without further ado, let's start. We just classify them. Our ub will be ln of x, and then dv, which is, it's actually v, ln of x, then open close parenthesis, minus integral of, look for our v, which is 4 over x x to the 4th power over 4, once again, times 1 over x dx. After that, we just gonna, so it will then be equals to, or when we try to solve it, equals to 1 over 4 x to the 4th power ln of x, and then minus, after that, 1 minus 4 over 1 over 4 integral of x cubed dx. There we go. So we just copy the other parts here, equals to 1/4 x to the 4th power ln of x minus 1/4, and the integral of x cubed, which is x to the 4th power over 4 plus c. You just then multiply it like this. Take a look at this. 1/4 x to the 4th power ln of x minus 4 times 16 minus 1 over 16 x to the 4th plus arbitrary constant. So we have now our final answer. Hello everyone, so I'm going to be presenting to you a tutorial video how to solve a integration by using u substitution. Problem is integral of 2x x cubed plus plus 2 dx. What we're gonna use now is, I usually use the one with the close and open parenthesis for my u. So I will let u be equals to x cubed plus 2 du dx our du or dx will be will be 2x, and then our derivative of u will be equals to 3x. Oh, sorry. Open C, and then now we will just substitute it. Integral of u instead, du. Just bringing it down, it will become, we will find the antiderivative here. 1 plus 1 1 plus 1 du, that will become u 2 over plus c, and then we just substitute it from the original, which is x cubed plus 2 over 2 plus arbitrary constant, and there you have the final answer. Thank you. Hello everyone, so now let's get to solve the second problem, which is the integral of x squared sine times x cubed plus 4 dx. First, look for the u, which is the one I always prefer inside the closing open parenthesis, which is the x cubed plus 4, and then the du over dx, which is equals to 3x squared. Our du is just the same, 3x squared, but this time it has dx. And then if we try to bring down the derivative and exchange it with dx, this is what it will look like. Du over 3x squared equals dx. Now we have our problem here. We will replace dx with this. Bring down now x squared sine, and instead of this equation we substitute it to u, so it's gonna be u here, u times du over 3x squared, and then both of them are x squared, so you just cross them out. It's also understood that the numerator here is 1, so it's gonna be 1/3 here. 1/3. Just copy sine u and du. But let's also not forget to find the antiderivative of sine, which is negative cosine. 1/3 negative cosine u du plus c, but we should also we will multiply these two. It will now come out as negative 1/3 cosine u du plus c, and then for the final answer will be negative 1/3 cosine, and I'll just substitute it again, x u plus 4 plus c, and there you have the answer. Thank you for watching. Hello everyone, so now we're going to be solving an example of trigonometric substitution. We have the problem x over square root of x squared minus 1 dx, and then we have three ways or formulas. we will use the number theory, which is the integral of square root of u squared minus a squared equals to x equals a secant theta. So now let's start. First, try to substitute it and use it our formula here. It's a squared, and then I'll look for x, which is a secant theta. Our a squared is equals to 1, a is also equals to 1. Now our x will be equals to x secant theta, and then our x squared is equals to secant theta secant squared theta. We will also look for dx, which is the derivative of x is equals to secant theta tangent theta d theta. Now let's just incorporate what we have got already. Integral of secant theta times secant theta tangent theta d theta over square root of secant squared theta minus 1. And then what we will do here, we will multiply these two, equals to secant squared theta tangent theta d theta. We'll solve for the, since this is secant squared theta, it will be, look for its derivative, I think, which is tangent squared theta. After that, we will cancel since they are similar, cancel, but there's still a tangent that will remain here at the bottom, and this is what it will looks like: secant squared theta d theta over over equals to tangent theta plus c. So in order to return this to the top, we will base it from our x, which is x equals secant theta, to a triangle. Also, we all know that secant theta is equals to 1 over cosine theta, and what we will do here, we will transfer cosine theta at the left side, and it would look like cosine theta equals to 1 over x. And now I base our triangle here. We place here our adjacent, and then our x, which is the hypotenuse of our triangle. Now after that, we will base it from our denominator, which is the square root of x squared minus 1. And everything will be based for solving our tangent theta plus arbitrary constant. And we will just base here our tangent is equals to square root of x squared minus 1, and the adjacent of this is actually 1. So to become x squared minus 1 plus c. And there you go, our final answer. I would like to thank that YouTube channel Daniel Patosa for helping me learn this kind of problem and try to solve this. Hello everyone, so we're gonna be working with our double integrals. So the first integral is 2 then 4 xy squared dy dx. So we will be focusing on the center or the second integral here. Now without further ado, let's start. So just bring down here 4 xy squared dy. We will be now looking for the antiderivative of y squared, which is we calculate them 2 plus 1 over here and 2 plus 1, which equals to xy cubed over 3. And then after that we will evaluate our limits here, which is we will place y here, and then it will become here x over 3, and then we just evaluate this 2 4 cube minus 1 cube. Let's solve that using the power formula. Instead of 4 times 4 is 16 times 4 it's 64, and then times 4 again. If you calculate it, it will become, wait for a few seconds, I'm about to calculate it now. Just few seconds, and then 4 cube. I actually forgot it's already 64. My bad. And then just minus 1, which will become 63. Equals to 63. 4 times 4, 16 times 4, 64. Now that we already get it, we will multiply this 2 to become 63 over 3x. And then what we will do now is place it here, equals to our second integral, or technically the first one, but we use the inner part. So this is the outer now. It will become 63 3x dx. Now bring it down here. 63 3, and then we will add, we have a variable which is x here, we just add plus 1 here, 1 plus 1, since x is understood as 1 if there are no visible exponent other than 1. The limit approaches 2. We no longer have to place it x, since there's only one variable x here. So after that it will become 63 over 3 x squared over 2 limit approaches to 0. What we will do here is we can technically divide this. So but perhaps maybe. Let me try. 63 divided by 2 was 31.5 here. We have 31.5. We'll place it over here. Just say 0.53, and then we will incorporate it. So we have this problem here. Maybe I will try to, so in order to make it a little more easier, I will, instead of 4, 1 here, I will just replace it with 2. Yep, replace it with 2. It will become then 2 here. So instead of 1, it will be 2 times 2 is 4 times 2 equals 8. 64 minus 8 will become 56. So instead of 63 here, this is 56 now. Also, change this into 56. Change this into 56. And then we have even. We have 56 divided by 2, which is 28. We have 28 over 3 here. We have 28 over 3. And then we just substitute the evaluation by 2 due to our exponent being 2 here. 2 minus 0, 2. It will become 2 times 2. Obviously it's gonna be 4. Since we don't really necessarily need here, since 0 is when you try to any any kind of solution, or the way you solve 0, it will still remain as 0. Even how many times you will increase your exponent here, and for your power formula, it will still remain 0. So 28 over 3 times 4 equals to, just multiply it. 28 times 4, it's equals to 112 over 3. So there we have the first answer. Just to remind you, I changed it. It's no longer 1 here, it's 4. Thank you. Good day, so now we're gonna solve the second example, but this time this is a triple integral. Like the first or the double integral, we usually start in the middle part. So we're gonna start here, and dx. It's gonna be 1, 0, x cubed y z squared dz. This is dz here. So we will look for the antiderivative of z. Since it's z, we will be looking for the antiderivative of z squared, while x and y, we will just copy them, but we will treat them as constant. Z, I will no longer have to I will just shorten the solution here over 3 here. We have that, and then we will weight our limits, which is equals to 0 and z equals to 1. Then we try to, it will now become 1 to the third here. Take this out, x cubed y, and then evaluate our limit, also our antiderivative, which is gonna be here. So we will get our answer now. But first, we will just place it here. 3xy so it will become, it's just basically 1. So this will be our our inside now. We will be preparing it for 4 squared to 0, and we have a try to place it here now. 1 3 x cube 1. Just copy then dx dy. After that, it's time for our second integral, which is integral of 2 0. Just copy this one again. 2 0 1 3 x y squared. Forgot that this is now will become, instead of that, just copy this. This will be now the constant x 3 y dx. Now we will copy 1/3 y times x. We have x here, and then 4, which is the antiderivative of x. Since we are now focusing on dx here, it's the second integral now. It will be equals to evaluate of x equals 0 and x equals to 2. We can multiply these two, it will become 12 1 y, and then after that we will that's a new paper, apologize. 1/12 y equals to 2 minus 2 times 2 4 times 2 8 times 2 is 16, and this is just 0. So it will become 1/12 y 16 here. You can see it? Yes. I know you can see it. And then after that, and we can just simplify it or just make it smaller and less complicated. So it's gonna be 4 times 4 here. And 12 is 4 times 3. Or 3 times 4. And then take out 2. Of course you cannot take out both or the numerator or both in the denominator. If you're thinking this is 4, you have to separate them, one from the bottom and one from the top. So it will be now equals to 4/3 y, and now we are now heading to our final integral. So now that's solved. I already wrote it. Just copy 4/3 and then y squared over 2. Antiderivative of y to the first power is 2. And now with our the evaluation of limits, which is 2 to 4. So we can also divide 4 to 2. So it will become 2 here. 4 divided by 2. Just take them out. So let's continue here. We will place now equals to 2/3 y squared with a limit of 2 to 4. What we will do now is, like we always do, we will just substitute this 2 here for the 2 to the antiderivative of y, which is 2. It's gonna be 4 squared, oh it's itchy, minus 2 squared equals to 2/3, and then 4 times 4 is 16, right? 2 times 2 equals to 4, 16 minus 4 equals to 12. So I don't know if you want to solve it longer or to make it more understandable, you can just place here 16 and 4. So if you still minus it, 16 minus 4 is still the same, it's 12. So you multiply 2 to 12, it's gonna be 24 over 3. And you cannot no longer simplify since we have already 3 here to the denominator. So this is our final answer, and thank you for watching.